Alright, so this is lesson 2.2. We're going to put an A on there. It'll probably end up being 2 videos. We'll see. College Algebra, the complex numbers. You've already done things with complex numbers, so this is just going to be pretty much a review of things that you've already done. Complex numbers are basically all the numbers in the whole history of the universe. They include real numbers, and they also include imaginary numbers. Remember, imaginary numbers, we use the letter I to signify an imaginary number. An imaginary number is basically the square root of -1. Okay, you can't have a square root of a negative. There's not two numbers multiplied together that give you a negative, let alone a -1. So that is a number that is not a real number, and it is an imaginary number, because sometimes you will get x squared equals -1. And remember, in order to get rid of that x squared, you take the square root of both sides, and it gets rid of all that. And what do you get? The square root of -1. So it is a real live answer. It's something that you do get, but it is an imaginary number. So if we have a graph, and we have parabola right like that, and this is the function of x equals x squared plus 1, so it's a function. What we know is it does not cross the x-axis, so therefore we say it has no answer, because remember in the last section we talked about whenever it crosses the x-axis, that is the answer. Those are the roots of the problem. So if it crossed the x-axis, we have two answers for our x. Okay? But since it doesn't cross the x-axis, we don't have any answers, but we still have the graph, and that's where the imaginary piece comes from. So, anyway, just teaching you how to use imaginary numbers is pretty much all I'm going to do here, and I'm just going to kind of go fast over it because, again, we've done it before. All right, what I've taught before, whenever you have a negative underneath a radical sign, take the negative off and instead replace it with an I outside the radical sign. That's pretty much all there is to it. Square root of -16. Again, we take the I out, and then square root of 16 is 4. Okay? Negative square root of -13 equals negative square root of 13i. Let's go with D on example 1. Negative square root of -64 equals negative square root of 64i. Square root of 64 is 8, and we get that. Okay, so nothing really too complicated. E gives us square root of -48, and again, if you just remember, your first step is to take out that negative and make it an I. Now we can look at the 48 and change it to 16 times 3i. Take the square root of that. Square root of 3 doesn't do anything, and we end up with that. I don't like it written like that usually, though. I usually like to do this. Just keep everything in the radical close to each other. But the reason they do it this way is because bottom of page 194, complex numbers, basically what they're saying is any number in the whole history of the universe can be written like that. Okay, so let's say the number 4. 4 can be written as 4 plus 0 i's. So this is the real part, this is the imaginary part. 0 times I is 0, so 4 can be written as 4 plus 0i. If I have a number like 3i and I want to write it like this, I would write the real number, the real part is 0, and the imaginary part has that. Okay, so that's just the correct form to write imaginary or complex numbers in. And every number can be written according to that. A real part, A, and an imaginary part, BI. All right, let's look at addition and subtraction of complex numbers. And really what all we're doing is pretending, okay? I is not a variable. It is not like an x. It is an imaginary number. But it's used, or it's treated as if it were a variable when you're adding and subtracting. So we add our 8 and our 3 together, we add our 6 and our 2 together, and we get a number like that. The same is true when you're doing subtraction. If we had 4 plus 5i minus 6 minus 3i, take the parentheses off. Remember, when you take the parentheses off, all the signs change after the negative. So then we got negative 2 plus 8i. And see, this is written in a plus bi form. The real part, the imaginary part. And that's important to do. Make sure you write these in the correct format there. And that takes us to 196, where we're doing multiplication. All right, again, when you're multiplying, like I say, take out the imaginary part first. Now, the book does it differently, and I'm sure it's probably more correct, but what I'm teaching you works, okay? So what they do is they take out, instead of just the negative, they take out a negative 1, and then they do this. And then they change that to an I, which equals 4i. Okay, so that's what they do. The only difference between what I do is I skip that step, and I just say this is square root of 16i equals 4i. So I kind of skip a little bit. All right, so if we are doing a multiplication here, and we have the square root of negative 16, and we're multiplying it by the square root of negative 25, again, I take the I out, or I take the negative out. Okay, take the square root of that, square root of that, and I get 20i squared. Okay, so I get 20i squared for an answer. All right, I'm going to go a little bit off a little bit and teach you something here. I is the square root of negative 1. I squared equals negative 1. I cubed equals negative I, and I to the 4th equals 1. Every exponent on I above this will be one of these numbers. Okay, so let me show you what I mean here. And then we'll continue on with this. Well, let's just continue on with this now, and then I'll come back to this. Reason I did this is, what is I squared? I squared equals negative 1. So instead of an I squared, I'm going to put a negative 1 there, which equals negative 20. So that ends up being my answer for that. All right? Okay, so let's go. I don't want to do that. Let's look at I squared. I squared, we just look at our graph there and get negative 1. If I got I cubed, I just look here and I get negative I. What if I had I to the 8th? Okay. What is I to the 8th? Okay, a real quick way to do that is to see how many times 4 goes into this exponent. It's always 4. It's just the way it is. I've never heard of anybody else doing this before. It always works, but I don't know where I learned it. But anyway, I know I didn't make it up. I'm not that smart. But I to the 8th, we take the number up here, divide it by 4, and we get 2 with 0 left over. Okay, so we get 8 divided by 4 equals 2 with 0 left over. And that's all we care about is the remainder. We don't care what 8 divided by 4 is. All we care is the remainder. There is no remainder, so I to the 8th power equals I to the 0 is 1. Okay? If we had I to the 13th, 13 divided by 4, and what's our remainder is all I care about when I divide by 4. My remainder is a 1. So that means that equals the square root of negative 1, or I. Okay, so I to the 13th actually equals I. What if I had, and the book goes into this a little bit, what if I had I to the 37th power? Now, see, they do this long math process to find the answer. 37 divided by 4 is 9 with 1 left over. So I to the 37th is I. So if you look at example 4a, they have I to the 37th equals I. All right, let's do another one. I to the 58th power. That's the B part of example 4. Okay, how many times does 4 go into 58? Okay, 14 with 2 left over. So I squared, 2 left over, which means we get -1. I to the 75th, that's the C. Let's see, 20, what goes into 75? 37 goes into it twice. So what is it? 18 goes into 75 4 times with how many left over? 2 left over. Or 3 left over, I'm sorry, it's 72. 3 left over, which is -I when you have I cubed. Okay. What about D? It says I to the 80th power. I to the 80th. 80 divided by 4 is 20 with 0 left over. So anything to the 0 power is the number 1. Okay, so that's just a real quick, easy way. You just have to learn these and you can figure out what I to any power is. Alright, so let's jump, kind of going back and forth a little bit. I hope that wasn't too confusing. We went over it last year in Algebra 2, so you should remember that, us doing that from last year. Alright, so let's go to example 3b, and it's 1 plus 2i times 1 plus 3i. Doing the FOIL method, F, O, I, L, 1 plus 5i plus 6i squared is -1. So we have 1 plus 5i minus 6, so -5 plus 5i in the form a plus bi. Okay, not too bad there. And we'll jump and try to get one more out of the way before I run out of time. And we have 3 minus 7i, the quantity squared. Alright, so we're going to do FOIL method. So 3 minus 7i times 3 minus 7i, F, O, I, L, 49i squared. So these, oops, that should be 21, shouldn't it? 9 minus 42i plus 49 times -1. So So 9 minus 49 is -40 minus 42i. And again, it's written in the form a plus bi. Okay, number first, imaginary part second. Alright, so that's it for this first video. We'll start with conjugates and division in the next one.